Hello everyone, this is Vigneshwar from first year of Computer Aided Structural Engineering, Mahindra University. As a part of my curriculum, I am doing a project on infrastructural health monitoring under the guidance of Professor Visalakshi Talakokula, and my project is about fabrication of smart washer. As we all know that bolted joints are the most predominantly used joints in the assembling of steel structures to ensure its integrity and the stability. However, detecting the potential damage in bolted joints poses significant challenges due to the limitations in existing inspection methods. Conventional approaches often require expensive equipments and invasive inspections to monitor the health of a bolted joint, which may be impractically costly. So, in order to address this issue, my paper presents the design and development of a piezoelectric sensor based smart washer for structural health monitoring. So let us see deeply about this project. And talking about the introduction, smart washers are type of washer which we are generally using it in bolted connections, and I am incorporating a piezoelectric material called lead zirconate titanate into that washer in order to collect the response from the bolted joint. So this PZT exhibits the unique property of generating electric charge when it is subjected to mechanical stress. So this makes that PZT highly versatile and suitable for a wide range of applications in various industries. The main objectives of my projects are vibration control, energy harvesting, sensing and monitoring, integration and miniaturization, performance optimization, bolt looseness detection, etc. So talking about the working principle of my project, the smart washer which incorporates a PZT, that PZT can act as both actuator and a sensor. While an electric charge is given into that PZT, it can act as an actuator to generate stress waves on the bolted joint. So that stress waves travel across the bolted joint, and it collects the various informations about the body, and it comes back to the sensor. So that PZT can act also as a sensor to detect the stress waves that traveled across the body, which has all the informations about the structure in it. So the fabrication of my smart washer involves various steps such as designing and planning, material selection, sensor selection, installation and bonding, electronics and integration, assembly, testing and finalization. These are all the process involved in the fabrication of my smart washer. So as an experimental procedure, I am going to explain you practically how I did my project. So I took two steel plates in order to provide a bolted connection. So this is the smart washer which I am adapting here. This is washer number 1, this is washer number 2. Each washer has a PZT sensor installed in it, and I surface bonded a sensor also into the steel plate directly. So we can detect the entire response from the structure. We can collect the signature from this structure. So the two steel plates connected by nut and bolt. The bolt size is M24 bolt. The bolt which I am adopting is M24, which the internal diameter is 24 mm. So two smart washers are installed on the both sides, as I said earlier. These two washers have PZT installed in it. So the dimension of my washer is, the washer inner dia is 24 mm, the thickness of my washer is 12 mm. The thickness of the washer is 12 mm, and the clearance which I gave to provide sensor is 10 mm. So this is what I did as a connection to test my feasibility of my washer and efficiency. And the washer which I took is PZT patch of 5 mm. So the size of my PZT patch is 5 mm into 5 mm. The thickness of my PZT patch is 0.1 mm. So I took coaxial wires. These coaxial wires I used to solder it into the washer, into the PZT, and I bonded that PZT bonded washer into that structure. So after soldering I did a functional verification for soldered PZT patch. So and I came to know that the PZT patch successfully soldered, because I am getting enough peaks on my signature. So this is ready for use and further implementation. After bonding the PZT sensor into the washer, I tested the sensor for surface bonded response. So the surface bonded response also shown enough peaks. So it means that the washer is functional. And we can use it for further. After bonding the sensor into my washer, I did epoxy coating in order to protect my washer from external disturbances. So after this, these are all the steps I followed to fabricate my washer. After fabricating my washer, I just assembled all the steel joints, M24 bolts, smart washer, and the surface bonded PZT sensor. This is also epoxy coated in order to protect it from external disturbances. So this is what I did. This is the assembly which I took in order to test the functionality of the washer. After assembling, so I collected ideal signature and I induced the damage into bolt, which means I loosened these two bolts up to certain value. So at ideal state, while the bolted connection is proper in its ideal state, I collected the baseline signatures for PZ washer, smart washer 1, smart washer 2 and PZT sensor. After this, I collected baseline readings from all these three sensors so that I can compare it with the damaged state. So this is the response I collected from the PZT 1 which I installed it in smart washer 1. So the PZT the green line indicates the ideal state of the connection when it is properly when the bolt is properly connected. So this shows us how, and the red line indicates the damaged state when after incorporating some amount of damage in this bolt, which means loosening of this bolt. I can clearly see the red color which shows maximum peaks because of the damage induced in the structure. So this is the response I got from PZT2. The PZT2 also, this green line clearly indicates that the ideal state of the structure when the bolted connection is proper, and after loosening the bolt I got damaged signature also, which can be clearly seen in red color. So the surface bonded sensor which is here, this sensor I collected response from this sensor also. In this sensor the green color indicates the ideal state of the connection and the red color indicates the damage. So the conclusion is we can clearly see that whenever there is a loosening in the bolt, the signatures are varying from its ideal state. So we can able to identify if there is an damage or loosening in that point of connection. So this is how the smart washer works, and the conclusion of my project is this project significantly enhances the safety and reliability and the maintenance efficiency in steel structures. Further, the proposed technology can lead to reduced maintenance costs, increased operational efficiency and enhanced safety by enabling early detection of potential failures in bolted steel structures. Thank you.